Hello everyone, welcome to Geeks for Geeks. In this video, we are going to make a Streamlit web app for spam classification. So first of all, what is Streamlit? So Streamlit is a Python library that helps us to make beautiful web applications. So first of all, we are going to make a natural language processing model, and that model we are going to feed into a Streamlit web app. And this web app is going to classify the text that we are going to provide it as spam or not a spam. So here as you can see, we have to write a sentence and it is going to predict whether this sentence is a spam or not. So let's write a spam message. Let's say we write congratulations, congratulations, you won a lottery of 3,000. Let us predict. So as we can see the prediction, this message is looking spam. Now let's try to predict a message which is not a spam. Let's say someone is writing to another person an email like, please come to my birthday on the coming Sunday. Let's try to predict it. And we can see the prediction. This message is looking not spam. So let us try to make this model. So on my desktop, I have created a folder called Python project. Inside I've created a folder called Geeks for Geeks, that is GFG. And inside I've created my project folder called Spam Streamlit. So you can create your project folder wherever you want to create. And in this project folder, I have saved this image which you saw on the web app. This is our dataset, and this dataset link you can get in the description. And this is my main file in which I'm going to make the model, and I'm going to also make the web application using Streamlit. So let's first of all see the dataset. As you can see on the dataset, we are having two columns. First column classifies the message as ham or spam, and the second column stores the message. Now we are going to analyze this dataset. We are going to remove the stop words. We are going to make a simple NLP model, and that model we are going to use for our Streamlit web application. Now in the project folder, you have to create a simple file and you have to name it as webapp.python. Make sure the extension of the file is .py. Now open webapp.py. Now we are going to import the important libraries and we are going to start coding the web app. Now first of all, we have to import Streamlit, then pandas, numpy, matplotlib, all such libraries. So make sure you have installed these libraries in your project folder. So for that thing, you can go on command prompt. And to download these libraries universally for your C drive, you can just write pip install Streamlit and run it. Then you can see that requirement already satisfied because I've already installed it. Then let's say you want to install pandas. Then you can run pip install pandas and pandas will be installed. So like this, if your compiler says that this library is not installed or the statement cannot be resolved, then you can install that library. So we have to import Streamlit as st. Then we have to import pandas as pd. Then we have to import numpy as np. We have to import re. Then import nltk, that is natural language toolkit. Import sklearn. So all these libraries I have installed and the syntax is going to remain the same. Pip install library name, right? Then we have to import count vectorizer and that is present in from sklearn dot feature extraction import dot text import count vectorizer. Perfect. Now we can download the stop words. nltk dot download stop words, and from nltk dot corpus we can import stop words. So we have imported all the libraries that we are going to use in this NLP model. So first of all, let me put a comment NLP model. So first of all, let's work on the natural language processing model, right? So first of all, we have to read the dataset and convert that dataset into a data frame. So that thing we can do by pd.read_csv, and you have to write the complete raw path of your CSV file. So just come to your project folder, copy this path and paste it over here. Backslash name your file spam.csv. So this is the name of my CSV file. Now let's print the first 5 rows. So df.head. So let's see what's there in our data set. So let's run it. And we can see that it gives me 5 columns, out of which only 2 columns are necessary for me, that is v1 and v2, and is unnamed 2, unnamed 3, unnamed 4 are useless columns because they are only containing the null values, and we can remove and we can drop these columns, right? So let's drop them. So we can do is df is equal to df.drop unnamed 2, and we can just copy this, paste it twice, and make it 3 and make it 4. So all the null columns will be removed now, and give the axis as 1, right? Now let's print df.head. Let's run it. Now you can see those null columns are removed. Perfect. Let's move on. Now as you can see that my main columns were named v1 and v2. Now I want to rename them as label and message. So let's rename them. df.rename columns is equal to, in a dictionary, name v1 as your labels and v2 as the message. Perfect. And you can write in place is equal to true. Now we have renamed the columns from v1 to labels and v2 to message. Now my dataset may contain some duplicate values. For them, let's first of all see the shape of my dataset. So df.print df.shape. Let's run it. I can see that currently it contains 5572 rows. Let's drop the duplicates. So df.drop duplicates in place is equal to true. And now let's print df.shape. Let's run it. And we can see that now the updated rows are 5169. That means my dataset was containing some duplicate values, and now those duplicate values are removed. Now my dataset is becoming cleaner. So let's move on to the next thing. As you have seen the dataset, the labels were named as ham or spam, but I want to convert them into numeric labels, that is 0 or 1. So what I'm going to do, df at labels is equal to df at labels dot map, and in a dictionary you have to name ham as 0 and spam as 1. So wherever my spam will be there, 1 will be replaced, and wherever the ham will be there, 0 will replace that ham. Perfect. Now what I can do next thing is, let's first of all see the dataset. Print df.head. Let's run it. And I can see that my dataset is containing 2 columns, labels, message, 0 and 1 are there, and the message is there. Now you can see that my message is containing some punctuations, then stop words. Stop words are the words like you, they, them, when, where, and these words are not useful for the NLP model. So I can remove such stop words, and I can remove the punctuation marks also. So for that thing, we have to import string. Import string. Let's move on. So I'm going to write a function called def clean data, and it is going to take a message, and let's write the function. So first thing, I want to remove the punctuations. So let's write message without punctuation will be in a list character for character in message if character not in. That means I want to consider only those characters which are not present in string dot punctuation. That means all the punctuations will be ignored, right? Next thing, I want to join all the characters which are not punctuations, right? So the final message without punctuation is going to be, I want to join them without a space. So dot join function, I'm going to use dot join and this message without punctuation, right? Perfect. Now I want to remove the stop words also, and I want to return the words which are not stop words, right? So all the words without the stop words and all the words without the punctuations will be returned, and they will be joined using a space bar, right? So let's return. For that thing, a separator I have to define, and my separator is going to be a blank space, because I want to connect all those words. Like my all the words will be in the list format. Now I don't want to return a list, I want to return a complete sentence only, but all the stop words will be removed, all the punctuations will be removed, right? So for that thing, I have to define a separator. So this separator is just a blank space, so all the words will be joined with a blank space, right? So return separator dot join. So using a separator, I want to join which all words, and those words I'm going to define in this list. Word for word in message without punctuation. So all the words in this variable, that is message without punctuations, will be taken, and I'm going to split them, and I want to check the condition. If that word dot lower, that means I want to convert that word into lowercase. If that word dot lower not present in, that is not in, I'm going to use stop words. Stop words we have imported, right? Stop words dot words English. Now what is the meaning of this line? Let's try to decode it. Let me decrease the font size. Yes. So what is the meaning? It means that using a separator, you have to join all those words which are present in message without punctuation, but those words should not be present in this stop words, English stop words, right? Perfect. I hope it is clear to you, and I want to return that string. So the function is ready. So this function is going to remove all the stop words and all the punctuations. Perfect. Let's move on. Now I want to apply this function to every message. So df at message will be df at message dot apply this clean data function. Perfect. So this clean data function will be applied to every message. Now I want to convert my data set into two parts, that is x and y. So x will be containing the message and y will be containing the class that is to be predicted. That is my labels class. So x will be df at message and y will be df at labels. Perfect. Now I want to apply count vectorizer, right? Because I have to convert all my words in a message into vectors. That is a very basic part of an NLP model. So CV, I'm going to define a variable that is going to store an object of count vectorizer class. Count vectorizer. Count vectorizer. Now I can apply this count vectorizer on my x. So x will be cv dot fit transform the x, right? So x will be updated now. Perfect. Now let's see what is saved in x by printing x, right? So let's print it and let's see what happens. So this is all my x. So all the words are converted into vectors, right? So let's move on. Let's remove this print x. Let's remove this df.head so that my console is clean, right? Now I have to import train test split because I have to convert my data into training and testing. So from sklearn dot model selection import train test split. Let's use that. So x train comma x test comma y train comma y test will be train test split my x data, my y data. Then you have to define test size. So I'm going to keep test size as 0.2, that is 20%. Then I have to keep random state as 0, right? So now I am ready with the final splitted data, right? So x train is ready, x test, y train and y test all are ready. Now I have to import multi-naive Bayes from naive Bayes class from sklearn, right? So from sklearn dot naive Bayes import multinomial nb, right? Now I'm going to use that model. So I'm going to name my model as model will be multinomial nb dot fit. I'm going to fit the model with the x train with the y train, right? So my model is also ready and I fit the model with the x train and y train. Now I can make predictions and I can check the accuracy score. So for checking the accuracy score and classification report, we have to import from sklearn dot metrics import accuracy score, classification report and confusion matrix. So we are going to print all the three things. So let's first of all make predictions. So predictions will be model dot predict x test, right? We have to make predictions for testing data and we have to compare those predictions with the actual y test data, right? So accuracy score, print the accuracy score between y test and my predictions. Then I want to print the confusion matrix between y test and my predictions. Then I also want to print the classification report between my y test and predictions. Let's run it. Now here you can see, let me increase the font size. Here you can see that the accuracy is 96.5% and from all the predictions, only 36 predictions were wrongly predicted. All the other predictions were correctly predicted. And this is the precision recall F1 score. And as you can see, it is very high. So that means our model is working perfectly. It is working nicely, right? So now we can move on the making of the web application. First of all, we have to write a function that is def predict. So this is the function that is going to take the text that the user is entering in the web app and it is going to return the final answer, right? Final predictions. So that function is going to take a text and we have to define the labels. And currently we are having two labels, that is not spam and spam, right? Only these are the labels that I have to predict. And the first of all I have to define x. It is going to convert or it is going to apply count vectorizer on the text that it has got as a parameter. So cv.transform text, and that transformed text I want to convert into array. So dot to array, right? Now I can apply model dot predict x, right? Now I have to apply the model on the x. Now let's see what this p returns or what is there in this p, right? So return p. Now I can call this function on any text. So let me call this function on print prediction, that is predict, and I have to give it a array, right? So I'm going to give a text called congratulations, you won a lottery. You won a lottery of $4,000. Let's run it. And we can see that it returns a list of only one thing, that is 1. And what is this 1? It is going to return you only two things, that is 0 or 1. So we can see that if it returns 0, then we can return a label that is present at index 0 of this labels list. And if it returns 1, that means it returns spam. Then we can return, or we can print the string that is present at index 1 of these labels, right? So what we can do is, for printing the final answer, instead of returning this p, we have to make one more string. Let's name it s only. S is equal to a list string of I for I in p, right? So for all the element that is present in p, I know that only one element is present, but all the elements that is present in p, I want to convert that into string. And one more variable, let's call v, is equal to int dot join s. And now I can return a string which says this message is looking to be, and a colon. Then you can return a space also, and you can return labels at position b, right? So if it returns 0, then the not spam will be printed. If it returns 1, then spam will be printed. Perfect, right? Now I can return this string, right? Now let's try to run it. So I'm getting the output as this message is looking to be spam. Perfect. It was a spam message, right? Congratulations, you won a lottery of $4,000. It is a spam message, right? Now only one thing is left, that is designing of the web application. Let's try to design it. So first of all, I want to put a heading on the Streamlit web app. So we can put it by st, that is the Streamlit object that we have imported as st.title, and you can name it as spam classifier, right? Then I want to keep a image, st.image, and that image name was spam.jpg, right? And you can see that in my project folder, image.jpg, sorry. Let's rename it image.jpg, right? Let's print this thing only. Let's try to run this. And one more thing I want to teach you, that how you can run a Streamlit web app, right? So what you have to do is go on your project folder, and first of all save this, control s, right? So go on your project location, and in this, that is your project location, write cmd, that is command prompt, and hit enter. So command prompt will be opened in this location only. As you can see, let me increase the font size. You can see that command prompt is now pointing to this location only, where my project folder is there. Now you have to write a line, streamlit run the name of that file, that is webapp.py, right? Hit enter. Now your default browser will open, and it is going to show you that web app, right? And we can see that only two things are displayed now, that is my title, spam classifier, and this image. Now here I want to take a user input and a button, right? So let's do it. So here I want to take a user input, and it takes st.text input, and we have to define a label. So let's write label, or we can say write your message, right? Now after this, I have to make a button, and that button I'm going to call as submit. So submit will be st.button, button, and yeah, and we can give a label to this button as predict. If this button is pressed, so for that thing we have to write if submit, which means if this button is pressed, then what you have to do, we have to answer a variable that is going to store the thing that this predict message is going to return me. So predict, and this predict function I'm going to apply on the user input, right? And I can return st.text answer, right? So finally an st text will be returned, that is Streamlit text will be printed, and in that text answer will be printed. Let's save it. So hit Control S, and we can go on the Chrome and you can see this button rerun, or you can just go on this menu and hit rerun. Now let's see what we get. So we get a text input field. So let's write a normal message only. Let's write, hey, I am Rohit. Can you share your notebook, let's say physics notebook, with me? So this is just a normal message, right? Let's try to predict. And we can see the output. This message is looking to be not spam. Perfect. Let's write a spam message. Hooray! You won jackpot of going to London, right? And let's write some exclamation marks. Let's predict. And we can see the output. This message is looking to be spam. Perfect. So I hope you like this video, and if you want to give us suggestions or feedback, then you can do that in the comment section. Thank you for watching this video.